Okay, we have written another integral from the MIT integration bee 2020, number 3. We have the integral from e to e to the e of natural log x times natural log of natural log x all over x dx. Okay, to get started with this, the first thing I notice really is we've got natural log all over the place, and what we can do is look for the derivative. Well, if I just kind of create a 1 right here, we've got the derivative of ln x right here, 1 over x. So then it seems like a u substitution can help us simplify this. If I just make u equal to ln x, then for our du value, take the derivative, this is going to become just 1 over x dx. So let's just go ahead with this substitution over here. So first we'll plug e to the e in here. Well, natural log of e to the e, well, if I just bring the e in front, we've got e ln e. This is just 1. So for this upper bound, we can just make this e. And then plugging in an e right here, natural log of e, that's just 1. So then let's go ahead and substitute everything. So first, natural log x, that's just going to be a u. ln of ln x, that's going to be ln u. And everything else is going to be just du. But now for this thing, this is actually a perfect case for integration by parts. We'll use the DI method or tabular integration over here to the right. So I just need one column to differentiate, one column to integrate. I'm going to differentiate natural log of u just because that's hard to integrate, and we'll integrate u. So we'll go ahead with this. Derivative of natural log of u is going to be 1 over u. Integral here, u squared over 2. So then we have part of our solution here on the diagonal. So we'll write this part down. We'll write this as u squared over 2, natural log of u. Here, this is all going to be an integral. But when I do this, we'll bring a minus up front. Then we have like a 1/2 I can bring up front here. And then the rest of it's just u squared over u, but I can cancel 1 and just write this integral as u du. So then we'll just go ahead and integrate. This is just going to be power rule, but let's copy down all the rest of this stuff. So we're going to have u squared over 2 ln u here minus 1/2. This integral is going to be u squared over 2. And for all of this, we're evaluating from 1 to e. But since we have this u squared and 2 in common, I think I'll just factor that out before I evaluate. So let's do this. We'll have u squared over 2 here. This is going to become ln u minus 1/2. And we're evaluating from 1 to e. So then let's just plug everything in. First evaluating the e, we're going to have e squared over 2. This is going to become natural log of e, but that's just 1, minus 1/2. Then we're going to have a minus sign plugging in 1. This is going to become 1/2. Natural log of 1 minus 1/2. Natural log of 1, that's just 0. Minus times minus here is a plus. 1 minus half here is 1/2. So putting this all together, let's bring it up into this area just because I've got room here. So what's going to happen is, let's rewrite, we're going to have this going to be e squared over 2 here. This again is going to be 1/2. And then here a half times a half is going to give me plus 1/4. But then 2 times 2 here is going to be 4. So what I can do is put this all over a common denominator of 4. So for my final solution, we're just going to have e squared plus 1 over 4. Okay, there you have it. Another quick one from MIT 2020. Thanks everyone for watching. Have a good day.